Good morning, all of you. Today I am going to make an audio recording for visually impaired student of Inorganic Chemistry book, Volume 3. Name of the chapter is Uses of Organic and Inorganic Reagent in Inorganic Analysis. First one, Introduction. Reagents are those compounds which are used in inorganic analysis for the detection and determination of ions and molecules. A large number of organic as well as inorganic reagents have been used for this purpose. The inorganic precipitating reagent generally precipitate the inorganic species as springly soluble salt or hydrous oxide. The organic precipitating agent forms springly soluble products either through coordinate linkage or through ionic linkage between the inorganic species and the organic precipitating reagent. Now, advantages of using organic reagent. The advantages of using organic reagent are listed below. First one is they are more specific than reagent under certain condition. Because of this property, they can frequently be used to detect a single type of ions in a complex mixture. Second one is they can be more sensitive. Classical semi-micro method of qualitative analysis will usually not detect much less than 100 grams of a substance under specific test solution. Organic reagents, on the other hand, are capable of detecting below 10 gammas and in certain cases as little as 10 to the power minus 3 gammas. Third one is they can be adapted in qualitative analysis. The organic precipitates are generally insoluble in water at a given pH and can be separated, dried and weighted. Those reactions giving color soluble product frequently show irregular changes in color intensity with concentration of the substance under test and so are adaptable to an accurate comparison with color representing concentration. This is the basic idea in the branch of colorimetry. Now, common property of organic reagent. Some of the common properties of organic reagent due to which these are used in inorganic analysis are given below. First one is formation of colored precipitate. Organic reagents form direct characteristic color with the ions to be detected. For locating endpoints, second one is formation of precipitate due to difference in solubility. This may be done on the basis of a gravimetric method. Third one is extraction in organic solvent at controlled pH. Fourth one is masking reagent. This increase the selectivity of reagent. Fifth one is difference in volatility. Sixth one is oxidation or reduction to other valency state. Seventh one is vast liquid. The chemical nature of the organic reagent is important in determining the uses of above mentioned properties. Now, advantages of organic reagent over inorganic reagent. It is it is due to the following properties that they are better precipitating reagent than inorganic reagent. First one is selectivity. In many cases, organic reagents are somewhat specific. For example, cobalt from nickel using alpha nitroso, beta naphthol or dimethyl glycosine, aluminium from iron using cupferron, cadmium from copper using quinidinic acid and thiourea can be precipitated. In some cases, adjustment of the pH will often cause precipitation of one constituent alone. By changing pH and solvent condition, one constituent after another can sometime be quickly precipitate out. Second one is ease of drying. Organic reagents produce compounds that have little affinity for water and are dried easily at temperature low enough to prevent decomposition. Third one is co-precipitation. Lack of ionic character of organic precipitation product greatly reduce co-precipitation in most cases. For example, the co-precipitation of sodium and potassium with magnesium is much less when the latter is precipitated by 8-hydroxoquinoline than when it is precipitated by phosphate or oxalate. Some exception in metal do occur. It has been little studied, but in some cases it is as bad as in inorganic precipitant. Reagents are usually insoluble in water, therefore it is important not to add an excess of reagent. This is difficult because there is no way to tell where when sufficient reagent without excess have been added, and any excess then that is insoluble would add to be weighted of the precipitate. Now, disadvantages of organic reagent. They are unfortunately disadvantages of organic reagent. First one is volatility. This is the first practical disadvantages of organic reagent because chelated compounds are non-polar. The force between individual molecules in the crystal are not very great. Thus, some of the metallic complexes which are precipitated in analytical chemistry are appreciably volatile volatile above 130 to 150 degrees Celsius and most decompose above this temperature. Therefore, the drying of precipitate should be done below 130 degrees Celsius to avoid decomposition. Second one is impurities in reagent. It is very difficult to prepare an organic reagent of the same degree of purity as say inorganic compound. Impurities present in organic reagent may enter into the precipitate during the precipitation and cause undesirable reaction. For example, first one is dimethylglycosim exists in three forms, that is alpha, beta, gamma. Of these, only the alpha form is specific for nickel while preparing dimethylglycosis. Gamma form is also formed along with the alpha form. If the precipitation is carried out with this impure dimethylglycosis, then nickel will be precipitated with some other metal because alpha form is specific for nickel whereas gamma form can precipitate out metal also. Ketoenol isomerism in some compound as dithiazone will cause error in colorimetric work unless conditions are carefully selected. Third one is low solubility of the reagent in water. This is the greatest disadvantages which organic precipitant have in comparison with inorganic precipitant. Fourth one is high molecular weight. The very high molecular weight of chelates complex formed with metal ions reduce proportionality, some error in precipitation and weighting. Fifth one is colored complex compounds. Chelates compounds are often highly colored and since they are usually soluble in organic solvents, they lends themselves to colorimetric or photometric method of analysis. Sixth one is solubility in organic solvent. Because of this covalent nature, most metals complexes with organic reagent are soluble in non-polar solvent, chloroform being usually the best. Some solvents are used to extract the complexes for colorimetric determination or they may be used simply for separating one element from other. Thus the complex of Cupferron with tripositive irons is very soluble in either, and chloroform, which allow one to remove large amount of iron from solution containing aluminium. In this extraction, the pH must be carefully adjusted to give the desired separation. Now, important organic reagent. Some of the organic reagent which are generally used in the identification of iron are discussed below. First one is oxine, C9H7ON. The structure of the reagent is given in the figure. It is almost a colorless solid soluble in organic solvent and mineral acid. It gives yellow color, which may be due to formation of cunoid structure. It was introduced by Ham and Berg in 1927, an analytical reagent. A number of metals give coordination complexes with this reagent. Examples of such metals are magnesium, zinc, copper, cadmium, palladium, aluminium, iron, gallium, etc. The formation of the complexes compound with a bivalent metal ions like Zn2 positive is given below. The qualitative estimation of the complex is carried out by drying and wetting the hydrated or anhydrous complex, or complex is initiated to oxide and then wetted. In volumetric method, the precipitate is dissolved by filtrating with hydrochloric acid, and then resulting solution is titrated against standard potassium bromide solution. In spectrophotometric method, the estimation of the metal ion is carried out by measuring the optical density of the complex. The reagent has been found to be suitable for magnesium, aluminium, etc. The reagent is a 2% solution of oxide in 2N-acetic acid. Second one is dimethylglycoism. This reagent was discovered by L. Seinghoff 1905 and was applied by O. Brunk 1907 for the determination of nickel in steel. The structure of this reagent is shown in figure. This reagent gives an insoluble red chelate with nickel 2 positive ion in ammonical medium. For detailed applications of the formation of chelates complex discussed in chapter on the basis of basic concept of coordination chemistry. Solution of palladium salt give characteristic yellow precipitate in dilute HCl or H2SO4, but nitrate ions interferes. Solution of bismuth salt also give a yellow color precipitate in presence of EDTA at pH 11 to 11.5. For all the studies, 1% solution of dimethylglycoids 1% of the dimethylglycoxime in alcohol is employed. In spectrophotometric method, the insoluble precipitate is extracted into chloroform, which yields yellow coloration, and then the optical density is measured. Third one is alpha nitroso beta naphthol, also called 1 nitroso 2 naphthol. The structure of this reagent is shown below. It is an orange brown powder having melting point 109 degrees Celsius, soluble in organic solvent but almost insoluble in water. The reagent is usually employed as a saturated solution in 50% acetic acid. This reagent is common for the precipitation of many metallic radicals, but it is used specially for the detection of ferric iron, copper, and cobalt, with platinum and uranyl salt in slightly acidic solution. It gives insoluble colored compound under suitable condition. Nickel and magnesium, however, are not precipitated by this reagent. Therefore, the reagent in acidic solution is used for the separation of nickel from cobalt. The structure of the chelates compound complex formed by the reagent with copper 3 positive ion is shown in figure. The reagent has also been used for the spectrophotometric determination of cobalt and a few other metals ions. It is also used for spot test of cobalt. Fourth one is Cuperon. Cuperon exists largely not in the nitroso-hydroxy form but in the tautomeric amine oxide form. The reagent is usually employed as a 6% aqueous solution but is most usually in strongly acidic solution. In strongly acidic solution, it precipitates Fe3, Ce3, Nb, Ta, Ga and Sn2, Cu2, etc. Precipitates should be filtrated immediately after their formation because cuperon is not very stable in acidic solution. Furthermore, precipitation should be carried out in cold since the reagent is decomposed into nitrobenzene on heating. The precipitates cannot be wetted after drying but most must be ignited to the corresponding oxide and then wetted. The formation of chelated complex with Cu2 positive ion can be shown as follow. Now fifth one is aluminone. It is an aluminium salt of arine acid. Its structure is shown in figure. It is brownish red powder freely soluble in water. It forms brilliant colored lakes with certain metals, especially aluminium, with which it gives a bright red lake. Aluminone is a dry and it is very important reagent for spectrophotometric determination of aluminium. By adjusting pH of the test solution below 7.8, it is possible to estimate 0.005 mg of aluminium even in the presence of calcium. The reagent is prepared by dissolving 0.1 gram of the substance in 100 ml of water. Sixth one is rubinic acid, also called dithioxamide. This reagent is the diamide of dithioxalic acid and is an equilibrium mixture with its tautomeric diimidoform. The SC form combines with nickel, cobalt, and copper to give colored water insoluble inner complex salt whose composition is shown. The copper, cobalt, and nickel compounds are qualitatively precipitated from strongly ammoniacal solution. In strong mineral acid, rubinic acid reacts only with certain element of platinum salt. In addition to above, rubinic acid form colored compounds with silver, mercury, bismuth, and iron. Rubinic acid is not only important as spot test reagent but also as a gravimetric and spectrophotometric reagent. Now seventh one is rhodomine B. It is tetraethyl rhodomine and is represented by the structure of given in figure. Solution of antimony salt is strongly hydrochloric acid react with rhodomine B and the aqueous solution of the reagent changes from red to violet and blue. Finely divided precipitate separates immediately or after standing. Trace amount of antimony may be detected in the presence of large quantity of the tin by means of this reagent. Small amount of iron do not interfere. Mercury, gold, platinum are precipitated, while molybdenate and tungstate in acid solution give color reaction with rhodamine be similar to those given by antimony salt. The freshly prepared benzene solution of rhodamine B is preferred to the aqueous solution. Next one is benzidine. Its structure is given in the margin in figures. It is basic reagent and is employed in slightly acidic solution as dihydrochloric chloride for the precipitation of sulfate as C12, S12 and 2 S2 2 positive, SO4 2 negative. The result precipitate may be titrated against standard alkali. The important drawback of the method is the relatively high solubility of the precipitate in water and even more in dilute hydrochloric acid. It also precipitates anions like phosphate and tungstate and give crystalline precipitate with a number of metallic ions such as silver, copper, cadmium, gold, zinc, etc. With copper and titanium, benzidine yields a blue coordination in alkaline medium, which is an important spot test for the metal ion. Recently, benzidine in dilute acetic acid have also been employed as a spot test reagent for the identification of some platinum metal like iridium and platinum. Next one is cupron, yeah, alpha benzoin. Its structure is given in figure. It is white crystalline solid. It is sparingly soluble in water but fairly soluble in alcohol. It also exists as in isomeric form. Cupron is used as a reagent for the quantitative determination of copper, molybdenum, and tungsten. Alcoholic solution of cupron give a green precipitate with ammoniacal solution of copper salt. Precipitation of other metal in ammoniacal medium is prevented in the presence of tartaric acid. The green precipitate is soluble in dilute mineral acid. Copper can be estimated both volumetric and gravimetrically by the reagent. The green precipitate is an inner complex whose formation can be below as cupron also precipitate molybdenum and vanadium ions quantitatively but in strongly acid solution. Vanadium give a yellow precipitate while molybdenum give a white precipitate. Tungsten and platinum also appear to be quantitatively uh, precipitated with alpha benzoin oxide. Next one is magnesium. The structure of this reagent is given in figure. It is also called para-nitrobenzene azoresorcinol. 1 to 0.5% solution of 0 in 0.25 normal in NaOH is generally employed. In alkaline solution, it forms a bright blue lake with magnesium ion. The sensitivity of this test is influenced by the presence of ammonium salt, so their presence must be avoided. Next one is alizarin. As it is alizarin sulfonic acid whose structure have been shown in figure. It is a dye whose sodium salt is soluble in water and is employed as an analytical reagent. Aluminium salt give a red precipitate with the violet solution of alizarin as in ammonia. This complex is an adsorption complex of aluminium with alizarin sulfonic acid. Adsorption system of this type of containing metal hydroxide and a dye stuff also called lake. Zirconium form red violet colored compound with the reagent under the alkaline condition. Boric acid also forms brilliant red color in UV light by alizarin in H2SO4. The reagent have been employed as a spectrophotometric reagent for the above metal ion as well as for few other. Furthermore, its applicability as adsorption indicates in the titration of FeCN6 4 negative MO4 2 negative have also been reported. Next one is nitroson. Its structure is given in figure. It is a yellow solid. It is insoluble in water but dissolved in acetic acid. Its 10% solution in 5% acetic acid is generally used as a reagent. Nitron with nitrate yield a springly soluble crystalline nitrate. C20H12N4HNO3 is soluble in solution acidified with acetic or sulfuric acid. Thus, nitron is a gravimetric reagent for nitrate, perchlorate, perrhenate, tetrafluoroborate, and tungstate also form insoluble salt and can be determined in a simple manner. Numerous other anions including bromide, iodide, chlorate, thiocyanate, nitrate, and chloromate interface but may easily be removed by prelim treatment. The result in the presence of chloride ion are generally high, possibly because of co-precipitation. Next one is cell cellular doxime. The structure of this reagent is given in the figure. It is white crystalline solid melting point 57 degrees Celsius, springly soluble in water. 5% solution of Celsius salicylate oxime in 50% ethyl alcohol is used as a reagent. The reagent decomposes in solution and should not be kept for more than about 3 days. It gives a yellow greenish precipitate of the inner complex of copper oxime with acetic acid solution of copper. Now some important inorganic reagent. Precipitating reagent NH3, common species precipitate aluminium Al3 positive, Fe3 positive, Sc3 positive, Cr3 positive, iron 3 positive. Wetting form of the precipitate is hydroxide M2O3. Precipitating reagent is S2S. Common species precipitate is Cu3 positive, Zn2 positive. Wetting form of the precipitate is CuO, ZnO or ZnSO4. Now precipitating reagent is S2SO4. Common species precipitate is Sr2 positive, Cd2 positive, Pb2 positive, Ba2 positive. Wetting form of the precipitate is M2SO4. Precipitating reagent is BaCl2. Common species reagent precipitate is SO42 negative. Wetting form of the precipitate is BaSO4. This is whole chapter. Thank you all of you.